right, starting light and breezy with a few square root graphs. Number 7 only has one transformation. Our parent graph is the square root, and we are moving it up 5 units. So if it helps you, you can actually graph that parent graph. The parent square root function at points at 0, 0, 1, 1, 4, 2, and 9, 3. Some people find it helpful to add those points to the graph so that the transformations become more of a counting game than anything crazy like building a new table. So what I want to do to each one of those points is shift them all up 5 units. So I used to have the point 0, 0. I'm going to move that up 1, 2, 3, 4, 5. I'm going to do the same thing to all of the other points on this graph. So that's one way that you can graph these. The other way is to just learn the patterns and play around with the graphs from their turning point or end point. I'll show that one in the next example. But this is one way that some people like to do it. If this is what you're comfortable with, I encourage you to stay with it. There's some information that they're asking us about this graph over here on the far right. Note that our domain didn't change from the parent graph. I don't get any negative numbers in here. This is just still all x's greater than or equal to 0. The range did change though. When we're talking about range, we want to find the lowest y value and then start looking up. So my lowest y value is 5, and then as I look up, I'm going to get every y value bigger than 5. Notice I have nothing down here. I don't have any negative y's. I don't have like 1, 2, 3, or 4 either. 5 is the lowest one. So my range is all y values greater than or equal to 5. Notice that that 5 is the same 5 that k gave us. So there is a relationship there. Our turning point is also related to h and k. 0, 5. Sorry, it's an endpoint for a square root function. But our endpoint is also related to h and k, and it's also related to the domain and range there. So you'll notice the same few numbers popping up quite often. 0 and 0, as well as the 5 and the 5. The next chunk here, this part that's called end behavior, we saw this with polynomials, although we didn't really play with them a lot after that. End behavior is just this idea that we can look at arrows or at endpoints and kind of get an idea of where the function is heading. So note that as x gets really large, it goes off to infinity. Our y values are also going off to infinity. You can see that with this arrow on the right-hand side. As x gets really, really big, y is also going to get really, really big. And you can think about that as a square root of large numbers, the square root of 100, the square root of 10,000. Y is going to keep getting bigger. The other chunk of end behavior is the left side. So we note that as x goes to, well, it can't go to negative infinity, so it has to go as far as 0. And as x goes to 0, y, or our f of x value, our function values, they go to 5. So end behavior is a bit weirder with square root functions than it was with polynomials. But at the end, we're still just looking at start and end values and also at arrows to see where this function is actually headed. We don't have to worry about increasing and decreasing intervals at the AB level. If you're curious at all, an increasing interval is just where is this function getting bigger. Decreasing just means where is it getting smaller. If we look at this picture, note that it's always increasing. So it's not a very interesting question for the square root function. Let's do one more example. Number 8. This is a square root function that is being shifted down 4 units and also 1 to the right. So this one is down 4, and also underneath the radical, that -1. Keep in mind that's the opposite of what we expect, so it's going to move right 1. So one way to do this is to graph the parent function and actually shift every point, down 4 and right 1. Another method, and one that I like because it's pretty quick, is to actually start at the end point. Remember that this right and this down, these h and these k values, those are the same as our end point. Our end point would be 1, -4. We can start there at -1. Let's try that again. Sorry, 1, -4. And then we can use the pattern. Keep in mind the square root function has a pattern associated with it, just like our parabolas did and just like our linear functions did. So the square root pattern isn't quite as nice as some of the other ones, but some of the points aren't too bad. Note, going from the end point to our next whole number point is just up 1, right 1. So I can do the same thing here. There's a point up 1, right 1. From that point, the next one would be up 1 and right 3. You can see that in the parent function as well. Up 1 and right 3. The next one will be up 1 and right 5. And then it would be up 1, right 7, up 1, right 9, those odd numbers. That's another way that you can graph one of these quickly. Up 1, right 1, 2, 3, 4, 5. That's another way you can graph one of these quickly. What I like about this method is you don't have to draw the parent graph and then move the whole thing. We can just go right to that end point and use the pattern from there. Feel free to use whichever method you prefer the best. We still want to answer some of these questions here. So our domain, notice that now I moved the graph to the right. So x is going to be everything bigger than 1. I no longer get 0 in this graph. Our range is also going to change because we moved the whole graph down. So the range is now everything bigger than -4. Note that -4 is now our new small value, and as I scan up, I'm going to get all the numbers bigger than -4 as well. It'll take the function a while to get there, but it will eventually get there. Keep in mind, end behavior just wants us to look at that arrow as well as that endpoint. So as x gets really, really, really large, y will also get really, really, really large. And again, it takes a while for y to get there. The other chunk of end behavior is the actual endpoint. So as x is going to +1, as x is going to +1, y is going to tend towards -4. And again, increasing and decreasing, we don't touch much at the AB level, but it's kind of boring. This function is always increasing. So this video's gone long enough. Take a look at these two examples, look at them closely. I do have one more, slightly more complicated square root, but before you watch that one, please double check that you understand where all these numbers come from, how to get these basic graphs plotted, as well as how to find domain and range and all those bits and pieces. If you're confused at all, please raise a hand. Let me know what you need, what supports would be helpful for you. Thank you.